Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be doing an introduction to the parent functions you'll be studying in this course. And we'll look at some of their transformations. Now, today's lesson will be a very brief overview on each of the function, and then throughout the year, we will go into each one of these functions at a more in-depth level. So our most constant function is our constant function, and it's y equals c, and it's just a horizontal line. So, for instance, if you had y equals 3, just a basic function, there's no variables, just a constant function. Then we have our first degree function, which is y equals x to the 1 power. This is called our linear function, and you should have studied this extensively in previous courses. And the linear parent function goes through the origin, and it's a slanted line with a positive slope of 1. All right. Our absolute value function is y equals absolute value of x, and it looks like it has a vertex at the origin, and it's a V-shaped graph that looks something like this. So that's your basic shape of your absolute value. When I was your age, I used to remember how it looked by the V absolute value. It looks like a V-shaped graph. All right, now our quadratic function, our most basic quadratic function is y equals x to the 2 power, or y equals x squared. It also has a vertex at the origin, but it is a U-shaped graph. So very similar to the absolute value, but you want to make it look like a U rather than a V. Now, the way I remembered this when I was your age, if it starts with a Q, it looks like a U. All right, so that's our quadratic parent function. Now, the square root function, now this function may be new to you. The formula for the square root parent function is y equals square root of x. And it has a vertex at the origin, and then it has a branch going off to the right. So that's the basic shape. All right. Our cubic function is y equals x to the 3 power. And it has one branch that kind of curves around to the top, and then another branch that curves around to the bottom. So that's the basic shape of a cubic function. The cube root function is y equals cube root of x. And here it has a branch going off to the right and a branch going off to the left. Our exponential function, y equals b to the x power, it goes through the point 0, 1, and it starts real small, and then it gets very big very quickly. It grows exponentially. You were more than likely exposed to that in a previous math course. Hopefully you remember it. Now, the next function will be new to you. We will study this in the second semester, but it's our logarithmic function, y equals log base b, so that's a little bit lower, and then of x. And it goes through this, the exponential function went through 0, 1. The logarithmic function goes through 1, 0. So it looks something like this. It goes off to the right and then down. Okay. And then our rational function is y equals 1 over x. And the rational function has 2 branches, one going this way and one going this way. Again, we don't expect you to memorize these right now. This is a broad overview, and you do not, again, need to memorize these. You will work with these functions so much that by the end of the year, you'll begin to recognize them in their basic shapes, okay? Now, in example 1, it says, describe the transformations and then make a rough sketch of the graph. Now, in problem A, we have f of x equals x squared minus 2. So right above it that this is a quadratic function. And you can tell by looking up at your chart. See where your chart had y equals x squared. In problem A, we have an x squared, all right? Now, this particular x, so we know we're going to have a U-shaped graph, and this U-shaped graph, this minus 2 would move it down 2. So all you're going to do is you're going to, instead of your vertex being at 0, 0, it's going to be at 0, negative 2, and then just make your U-shaped graph. It's a very, very rough sketch. All right. Now, in our next function, we have f of x equals the absolute value of x minus 3. So go back up to our chart, find the absolute value parent function, and remember its basic shape is a V. But here the 3 is grouped together with the x, so it's going to do the opposite. It's going to move to the right 3. So I want an absolute value or a V-shaped graph that's moved to the right 3. So put your dot here at 3 and make a V-shaped graph. Whoops, why did it turn into a U? I want this to be a V-shaped graph because it's absolute value. In fact, let's write that down just to help us remember these shapes. Absolute value. All right, problem C. We have f of x equals negative square root x. So let's find our square root function. So it starts at 0, 0, and then it branches off to the right. Now, let's label this as square root. But because there's a negative in front of it, it's going to reflect across the x-axis. So it'll still start at 0, 0, but instead of opening up and to the right, it's going to open down to the right. It just flipped over the x-axis. All right. Problem D, f of x equals 4x squared. Because we have an x squared, we know this is a quadratic function. So it's going to be a U-shaped graph. And this 4 is multiplied by the x squared. So that is a vertical, it's going to vertically stretch by a factor of BFO of 4. What that means is all the y values are going to be multiplied by 4. So this graph is going to become very narrow. All right, problem E. F of x equals 1/4 times the absolute value of x. So this is absolute value. So this is going to be a V-shaped graph. Now let's talk about what's going to happen to our V. We have a 1/4 in front. So this is going to vertically compress BFO by a factor of 1/4, which means our V is going to get wider. It's going to vertically compress. It's flattening out towards the x-axis. Okay. All right. F of x equals x plus 2 quantity cubed. So this is a cubic function. And the cubic function was right up here. It had one branch going off to the right and one branch going off to the pointing down, and it had a vertex at 0, 0. So this function, because the plus 2 is grouped with the x, will move left 2. So instead of having a vertex at 0, 0, we're going to have a vertex left 2 or at negative 2. And then it'll still point up on the right side and down on the left side. It still has the same basic shape. We just moved it to the left 2. All right. F of x equals 2 to the x minus 2 power. So this is an exponential function, and it's moving to the right 2 because the 2 is grouped with the x. So let's go back and look at our original shape. Our original shape goes through 0, 1. So I want to move that shape to the right 2 units. I want to move to the right 2 units. So now it's going to look something like this. Okay. All right. Log base 2 of x plus 3. So this is logarithmic. And because that plus 3 is grouped with the x, we'll do the opposite. So left 3. Now let's look at the basic shape of our logarithmic function. It's going through 1, 0. So instead of going through 1, 0, we want to move to the left 3. So 1, 2, 3. So here would be kind of like this. All right. And finally, we have f of x equals square root of x plus 1 plus 2. So this is a square root function that's been moved left 1 and up 2. So let's look at our square root function again. All right, it has an original vertex at 0, 0. So I want to move that from 0, 0. I want to go left 1 and up 2. So maybe right there. And then it's still going to go off to the right. Okay. All right, example 2. For each function below, indicate which function family it belongs to and tell what transformations it has undergone. So in problem A, we have a V-shaped graph. So I belong to the absolute value function. And let's see, the absolute value function, the parent function has a vertex at 0, 0. So this function has been moved to the right 2 and down 3. So right 2, down 3. All right. B. Now I want you to look at the shape of the graph in problem B. Then go up to your cheat sheet and see if you can figure out which parent function this function belongs to. All right. Hopefully you said that this function belongs to the square root function family. And the transformations are, now the square root function family, the parent function has a vertex at 0, 0. So this graph has been moved left 2 and up 1. All right. Problem C. We have a U-shaped graph. Go back up to your cheat sheet and see if you can figure out which function family this graph belongs to. All right. Hopefully you said that this graph belongs to the quadratic parent, the function family. And let's see what kind of transformations. Now, our parent function of the quadratic family has a vertex at 0, 0. So this graph has been moved right 1 and up 5. And this parent function also opens downward. So it's also been reflected across the x-axis because it's opening down. All right, D. Look at the shape of the function in D. Now go back to your cheat sheet and see if you can figure out which family this function might belong to. So looking at the cheat sheet. All right, hopefully you said it belongs to the cubic function. Now this function has moved 1, 2, 3 to the left. Left 3 units. All right. Try problem E on your own. Pause the video, and when you're ready to check your answer, press play. All right, welcome back. Let's see how you did. This function belongs to the quadratic function family, and the parent function of the quadratic has a vertex at 0, 0. So this is moved to the right 2 and up 3. All right. Next function. Try this problem on your own. When you're ready to check your answer, press play. All right, welcome back. This graph belongs to the exponential family, and the exponential family, the parent passes through 0, 1. So this function has been moved 1, 2, 3 to the right. So the transformations are right 3 units. And that concludes today's lesson, parent graphs and their transformations.